Chapter 1, Section 4 deals with classifying matter. One thing matter can be classified into are compounds. Compounds are products of elements that have been chemically combined. We may have covalent compounds where electrons are shared between those elements, something like sugar. And you may also have an ionic compounds such as salt. Where you have a transfer of electrons that occurs between the elements in order to chemically combine them. An ion is an atom, or it can be a group of atoms that has a charge to it. So it has either given away some electrons or gained electrons in order to get that charge, and that is an ion. As of right now, we're just going to discuss some basic properties of acids and bases. When we get a little further in this semester, we will do much more detail, but for now you basically just need to know some simple properties. Acids generally have a sour taste to them, while bases taste bitter. Bases also have a slippery feeling to them, so if you get one on your hand, it tends to feel almost like you've got soap that hasn't been completely washed off. The pH scale is used to express acidity. It ranges from 1 to 14, and 7 is neutral. Anything below 7 is acidic, and anything above 7 is basic or alkaline. Litmus paper can also distinguish acids from bases. Acids will turn blue litmus paper red, and bases will turn red litmus paper blue. You may also use something called pH paper or hydrione paper that has a color wheel, such as this one here, that you can put the sample of your solution on there, and then what color it changes, you compare it to the scale given, and that will give you a pH value that you can then see whether that falls as an acid or a base. The other thing about acids and bases is that when you combine them, they will react with each other or neutralize each other to form salts, which are ionic compounds, and water. And that is an acid-base neutralization reaction. Some more ways we can classify compounds are into organic and inorganic categories. Things that are organic are going to be covalently bonded, and they're always going to be carbon-based. Some other elements that might be involved could be hydrogen or oxygen. Nitrogen is sometimes common as well, but they're always carbon-based. Things that are inorganic are simply those that do not fall under the organic category. When discussing chemical formulas, our book has divided it into 4 categories. Molecular formulas are the first type, and this is the one you're probably most familiar with. For instance, this is aspirin's molecular formula, C9H8O4, where it shows you what types of elements are present. We've got carbon, hydrogen, and oxygen, and it also shows you how many of each of those atoms you have present. A structural formula is one in which it shows the number of atoms and how they're bonded. So it gives you a little bit more information than the molecular formula does. For instance, water, its formula is H2O, but the way it's arranged is really with the oxygen in the middle. The 2 other types of formulas are the ball and stick formula, which is really more of a geometric arrangement, such as this diagram here. This is a methane molecule. Carbon is the black ball in the middle, and then the white ones surrounding it are hydrogens. And then the final one is shown in a number of pictures in your books. These are a space fill formula or space fill model. And this tries to demonstrate the closest version to the actual shape of the molecule. So this one here is also the methane molecule, but you can see the proportions are much more consistent to that of the real methane molecule than, say, this ball and stick version. And finally, we have mixtures that you can classify materials into. If it's not a compound, it may be a mixture, which is just a collection of 2 or more pure substances that have been physically mixed together. So these are not chemically combined like a compound, they're simply physically mixed together. And they can fall into 2 categories: homogeneous mixtures or solutions and heterogeneous mixtures. Now with a homogeneous mixture or a solution, all of the particles are going to be uniformly distributed. So some examples would be gasoline. The gasoline you put in your car, obviously you don't want it to have different chunks of material inside it. You want it to be uniform so your car runs smoothly. Air, tea, all of these things could be homogeneous solutions. A heterogeneous mixture means that the particles are not uniform. So like the soil, if you go out and take a sample of the soil, you're going to find maybe a rock, maybe some dirt, maybe a worm. You're going to get all these different components there. And if you go take a sample of the soil somewhere else, you might get different components as well. So that's not uniform. And that would be an example of a heterogeneous mixture. Here's just a couple more samples. We discussed the gasoline, a stream with gravel on the bottom. That would be a heterogeneous mixture. You get water, you get probably big pieces of gravel, maybe some smaller pieces of gravel, some sand. And then something like copper metal. Well, that's just simply a pure substance. It hasn't been mixed with anything yet, but it could be.